right, so it's a minute after the hour, and my name is Greg Levenhagen. I'm the MC for this session, and here to kick off and introduce the session using Storybook to build a better game engine with Kamran Ayub, and he is a full-stack engineer at Target. He's also a Pluralsight author and an open source contributor on the Excalibur JS game engine. With that being said, you can take it over. Welcome, Kamran.
Awesome. I'm pretty happy to be here. I finally get to talk about two of my favorite topics in the whole world, gaming and coding. So I hope you're ready for this, all right? Ever since I was a kid, I've loved games. I'm a lifelong gamer. I have a terrible memory and I don't remember a lot of growing up, but recalling what games I used to play brings back fond memories. One of the first games I ever got working on my grandparents' DOS PC was Doom, and shooters have always been a favorite of mine. When I was a bit older, my grandma got me a game called Red Alert at Goodwill, and she unknowingly triggered a phase of intense love of real time strategy games. In high school, my best friend got a game called Morrowind, a fantasy role playing game, when he bought a new graphics card, and I remain a loyal fan of RPGs to this day. When my son was born, I'd let him sleep in my arms as I finished Horizon Zero Dawn. And I love all kinds of games. I've always enjoyed Nintendo games, and that's why today, after this presentation, I'll be checking on turnip prices in Animal Crossing. So if you couldn't tell, I really, really love games. I've even combined my love of coding with my love of games with my side project, Keep Track of My Games. It lets gamers manage their game collection and track new releases. In fact, I made it because there were so many games I wanted to play, I couldn't keep track of them. So I made a site that notified me when they were coming out. So, given that I love games so much, it might surprise you to learn that I am not a game developer. Well, at least I don't work in the industry. No, I'm just a regular old enterprise front end web developer. I work for an obscure retailer you've probably never heard of, but hey, listen, just between you and me, I'm only there because I get discounts on games. No, I don't get to do much in the way of game development at work. So I decided it would be fun to help build a game engine. It's called Excalibur JS, and it's a JavaScript or rather TypeScript based game engine for the web. I figured if I help make an engine, I can make games and help design the thing that makes games. It's super meta, right? And this worked out well because I'm not a C++ programmer. And at the time when we made Excalibur around 2011, Unity was still in its infancy. There was really no free open source game engine at the time. There were paid ones, but not any free open source ones. Excalibur was created by my very close friend, Eric Onerheim. Pictured here was some other clowns who we routinely build games with. I snapped a photo of nearly everyone on their phone during a game jam. Now, as it happens, Eric gave a talk earlier today, right before this, about web-based game development. So please check that out if you're interested in how Excalibur was actually built and how to build your own game engine. I'm here to discuss a different aspect of engine development, and that's testing a game engine. How do you even test a game engine? I mean, everything is visual, right? So pixels moving across the screen at 60 frames per second don't really seem suited to traditional unit testing. Well, the way that it works, at least in Excalibur, we divide things into two phases. There's an update phase and a draw phase. When we're testing the engine loop, we can disable the draw phase and just test the update phase. The update phase will update positions and do calculations, so we can at least verify what the engine thinks it will render in the draw phase. We use technology you're probably already familiar with, like Karma and Jasmine for testing JavaScript. We can set up our engine, which is a real instance of the game engine. And then in our test, we can follow the standard arrange, act, assert pattern. First, we arrange any setup we need, in this case, setting the actor position or actor velocity. And then we can act on the game engine by actually manually advancing the update phase by a certain time duration. So in this case, I'm advancing it by 1000 milliseconds or 1 second. Finally, we can assert on the properties we expect to have changed. And this is how we write traditional unit tests. Where it gets a little bit more interesting, though, is how to test that the engine is drawing the things correctly. After all, we can check whether the numbers look right, but we need to also know whether the pixels look right. So, in order to achieve that, we do something called image snapshot testing. Image snapshot testing is actually not too complex. We still use a real instance of the game engine, but instead of expecting on entity properties, we assert on image data. It turns out that the canvas element has a handy feature built in that lets you save the pixel data as an image or a PNG. So we take that PNG and compare it to a reference image, for example, during a test run where we manually verify that it looked correct. Now, if you've used Jest before and done snapshot testing for, let's say, React components, this works very similarly, except that we're doing it with images and pixel data. Now, there are definitely complexities associated with image diffing, such as rendering differences between platforms like Windows and Linux, anti-aliasing, which is a technique that removes jagged edges, color correction, and so on. This is especially true for font rendering, and if you ever have a chance to buy Eric a beer, just ask him about it. Image snapshot testing is useful for a lot of the tests that we write, but they can be elaborate to set up and test across platforms. So we do have one last way of testing if things work. Manual testing, otherwise known as integration testing. These are tests that we open up in the browser and manually verify that things look right. Well, how do we know what looks right? Well, it's only as good as the description beneath the test. Things like this: click to drag the red square. Look in the console for the right value. Yeah, this is a real screenshot of one of our manual tests. These are meant to be used only by us as maintainers to test out engine features before release, just to make sure we didn't actually accidentally break something. We always do end up finding something each time we do a release that breaks one of these integration tests, though. So they are handy. The way that we implemented these wasn't very fancy. We created dedicated HTML and TypeScript code that spin up a new game engine to test that code. We open a browser and navigate to the file. And that's the way that we've always done it until very recently. Enter Storybook. I mentioned that my day job is at Retail Megacorp Incorporated, and there I work on building JavaScript applications using React. One of the tools we use to develop our components built with React is called Storybook. If you haven't used Storybook, it's built as a way to do isolated component development where you can put your components into different states and switch between them to help make it easier to develop without spinning up your entire application. Now think about the way you might test a navigation menu as a logged in user. First, you would probably start up your app. Then you would log in. And then you would click the dropdown of the nav menu and manually make sure it's showing the right stuff. And you could write an automated test to maybe do that. But you have to do that every time you want to verify that the menu looks right. Just back and forth, back and forth. Now with Storybook, you instead make a story that describes the state you want to display a component in, like our nav menu with a username. So that's the state of our story. It has a username. And then you write your story in the JavaScript using your component and pass it all the props it expects so that it gets rendered in that state. Storybook will render your isolated component in that state, making it easier to tweak without having to run through all those manual steps while your application is running. Each story is isolated from each other, making it easy to represent all the different component variations you might have. So at its core, Storybook is designed for this isolated visual component development workflow. That's pretty awesome, but what does this have to do with building a game engine exactly? Well, that whole spin up a server and serve individual tests that run the game engine so we can make sure things look right, that sure sounds like a similar workflow to what Storybook promotes, doesn't it? I thought so too. And when I looked into it further, I discovered something pretty awesome. Storybook is framework agnostic. And I think this is important because I feel like too often Storybook is talked about only in the context of React component development. But there's actually support for a ton of different frameworks like Angular, Ember, Vue, and of course, plain old HTML. So that's right. Storybook can render pretty much anything that outputs HTML elements. And that got me thinking, since Excalibur renders to an HTML canvas element, could I migrate our old visual tests over to Storybook? And of course, the answer is yes. Otherwise, I wouldn't be here today. So let me show you. Here's a short tour of Storybook in case this is brand new to you. On the left side of the screen, we have our list of stories. Now remember, a story is an isolated piece of code that renders something in a specific state. On the right, where it's big and blue, is our canvas area. Now Storybook uses the word canvas, but it's different than the HTML canvas element. It's the area where the story gets rendered. This is where your React, Angular, Vue, etc., whatever gets shown. And like I mentioned, I'm actually showing an HTML canvas here with the game engine running. You maybe saw the heart at the beginning that faded out. Now on the bottom is a massively powerful feature of Storybook called add-ons. I'll talk more about what add-ons are available, but this one is called knobs. So let's actually tweak the parameters of this story. I'm going to say update the duration to maybe, instead of 200 milliseconds, let's try 3 seconds. And Storybook is going to rerun and re-render that story, and Excalibur is going to start up and is going to show me the preview of that new value. This auto reload mechanism is just built into Storybook. I didn't have to do anything except create these knobs. Now, this interface alone is enough to replace our old plain HTML server. But there's a lot more Storybook can do that doesn't just benefit us as maintainers, it can actually benefit our users. So let me show you the docs page. The docs area of a story lets you write out user-facing documentation. It's powered by Markdown and JSDoc and works especially well for component-based frameworks like React, as it can read in props and JSDocs attached to your components. For HTML, there is one major feature lacking, and that's the ability to just plug in any Markdown docs, but hopefully that's coming soon. There's an open issue for it. In the meantime, we can use another add-on called Source. So let me scroll down to this fade story that I showed you. Now, as a user, I can see exactly what the code was written to get to this result. This is pretty awesome because we as developers can actually try to promote best practices when we're creating stories. And you can even see down over here where I actually create the knobs that show up in the Storybook interface. Now, out of all the features in Storybook, I really think that this is the number one draw for us. Since Excalibur is not 1.0 yet, our API is heavily in flux, so we've avoided diving deep into making user-facing documentation. But since these stories are for verifying engine functionality, we have an incentive as maintainers to keep it up to date. And it makes it easier for us to present nice looking documentation to our users in addition to our automatically generated API documentation. Now let's talk about add-ons for a second time, since I mentioned that that's a huge feature of Storybook. Now I showed you 3 of them. I showed you knobs, source, and docs, but there's a lot more. There's actions, which can display a log of events, which we can use to showcase interactions or engine events being triggered. There's source, which you also saw in docs, but there's also viewport. So if you're doing responsive development, this adds the ability to create screen sizes for testing responsive designs. And there's a lot more official add-ons. These are all the official add-ons, plus there's tons of community add-ons. Now, as you can imagine, we have a ton of ideas for Excalibur specific add-ons we could make. And I'm sure if you were working with this in your own application, you could think of add-ons specific to your domain or business as well. Now, at this point, you might be saying to yourself, this is cool, but I don't make game engines. So how is this relevant to me? Well, let me lay down some wisdom for you for a second, okay? You are still drawing things to the screen. We both are, except in your case, it's probably nav bars and image carousels. In our case, it's a minotaur swinging his giant axe to protect his gold. But you and me still have to make sure our code renders the right stuff to the user, and for that, Storybook is a fantastic tool. Now, you can start to use Storybook today with whatever you're working on, be it a React app, a Vue app, Angular app, or nearly anything that renders HTML onto a page. And I have one last example for the remainder of this talk that I hope will explain how valuable Storybook can be in your own workflows. This is a pattern that I was used to being in, and maybe it'll sound familiar to any front-end developers in the audience. First, I would make my component. And then, because we do try to test our code, I would import that component into a unit test file and then put it into different states to test it and expect on the rendered result. And I use React, so this would be like using Jest with React testing library. And finally, we want to make sure the components work in the browser, so we'd use a tool like Cypress or Selenium to write a functional test. And it would be testing a page on the site. But since it's our app, we have to set it up to be right in the right state so our component renders correctly. So maybe you know where I'm going with this, but again, this sounds real familiar with how Storybook's workflow works, doesn't it? So at work, we actually switched to a workflow that puts Storybook at the center of each of these steps. For fun, let's just call it Storyflow. It's a name that I just made up right now, so feel free to tweet it or whatever. First, we start by making our component, just like we're familiar with doing. But then we actually change up our workflow by importing that component into our Storybook stories. And we make stories that put the component in states that we care about and want to test. Then we import these stories themselves into our unit test files, and we assert on what that story renders. Finally, rather than testing components in a functional test within the context of our site, we actually add tests that run against our Storybook site and test each component. Now, we still do write end-to-end integration tests that use the actual application, but we save those for testing workflows and user scenarios for regression testing. Now, the cool part is that the Storybook-based tests run faster, so we can tag them and group them separately in our project versus the more slower end-to-end tests that might be testing API integration and stuff like that. Now, of course, you don't have to follow this workflow if you're using Storybook, but we have found 3 major benefits using this Storyflow approach. The first is that we test against what Storybook renders, which means there's only one source of truth for all the tests instead of having to render a component in multiple ways across different unit tests or within functional tests. So that cuts down test complexity by a ton. The second major benefit is that this approach incentivizes writing more stories. Since we write tests against the stories, if we're missing a test case, we'll just add it as a story, which in turn makes that feature or bug or edge case visible to our consumers within Storybook. And that increases awareness across our team and our partner teams, because not just us, it's a bunch of other teams across Target. Now, more stories lead to more documentation of use cases, which only helps spread knowledge. Finally, the third benefit is that by writing stories, you end up making more testable components because you need to display them in different states. So concerns like fetching data or using global state, like from Redux, those get lifted up higher, and it leaves you with a more reusable base of visual components. Now, of course, I don't want to just talk about this. I also want to show this workflow off. So let's actually open the sandbox, and I'll show you what this workflow looks like. Now, I have a code sandbox set up to run Storybook, and I've written a login form component. So let's see if I can make this a little bigger. So this is what it looks like inside of Storybook. Now, there's a username, a password, and a login button. So this is pretty standard, right? Now, I'm using that Storybook add-on called Actions. So let me try and click on the login button here without entering anything. So I'm going to get some basic validation errors. And what we notice down here inside the Actions panel, actually, because I actually can't submit anything, there's no action. So if I enter, let's say, Carmonicus, password 123, which is my real password. Just kidding, of course. Now we actually see, no, thank you, LastPass. Now we can actually see what gets logged as the event using this Actions panel. So this is pretty useful. So whereas normally this might actually submit a HTTP request like to a server, I take that out so that Storybook doesn't have any concerns about where the data is going, and I just replace it with a callback that calls this action handler. So let's look at the code. Now, in Storybook, you write stories in a pretty familiar format, I hope, that you've seen before, where each exported function is a story. Now, this is the new way to write stories, because before you had to use a different API to create stories, and it was like something new that you had to learn. But this looks like just a regular React file. So at the top, we have this default export, and this provides some context to Storybook. And then any exported function, like this blank here, is treated as a story. And now in this case, since I'm using React, really this is just a plain old functional component. There's nothing special about this function that tells it it's a Storybook story. It's just that Storybook is looking for any exported function and uses that as the story to render. So as long as it returns some rendered result, like from React, it's going to display it in the story area. Now, this is where I'm creating my login form component and where I am passing this form submit action. So this action is imported from the add-on actions. And this is my submit event. Now in the actual app, this on submit would probably post to a server, like I said, but since I'm writing a story, I don't want to have it go out to a live server. Now, one benefit of writing your components first within these stories is that it helps you think about how to make them more testable, like I said. Speaking of tests, let me show you what it looks like to write a unit test where I actually import the story. So here at the top, I'm importing my blank story component from my stories module. And I'm using the popular testing library React. Let me just move this over here. And I use it the same way that I usually would, except that I'm not passing my login form component. I'm actually just rendering the story straight up inside the unit test. And now I can make assertions on that same HTML that's being shown here. So if I can, I don't think I can make this smaller. Here we go, canvas. So I'm actually asserting on this rendered HTML because I'm just importing the story. This goes back to the one source of truth that I mentioned as a benefit. Now, let me go ahead and actually run these tests in the terminal. So I should be able to click on, let's try this. There we go. Here's my tests. Now I'm actually running this inside of Code Sandbox. So hopefully this works. Now this is running jest, and it's running my tests here. So let's see it work. Now it's running the login form test, and I'm asserting that those validation errors are occurring when I try to click the submit button without entering anything. There we go. So one passed here. So the login form should not submit a blank form. Okay, now let me show you what the development experience is like when I update my component. So I have my test running here, and actually, why don't I do watch all, and while that's running, what it should do is anytime I change my component, it's actually going to rerun the test. So let's say that I want to change these error messages and I want them to be a little bit more polite. Maybe I want to say, please enter a username or please enter a password. So we'll do, please enter a password. Now you'll see that Storybook is going to re-render here on the right side. And then my tests are also going to rerun. So we'll do, I have to save first, of course. So once I save, then the test is going to rerun and Storybook should re-render. And I'll go down here while I wait here. Let's update this one. Please enter a username. All right. So because I'm using Storybook and Jest together, they're both going to automatically reload. That's just part of the local development experience. Since I'm using Code Sandbox, it's going to be a little bit slower than my local machine. But when we update it and it reruns, it should pass. So let's scroll all the way down here. And come on. I know we can do it. Let's just refresh the refresh here. So here we go. So now we can see the rendered output in the test. I don't think I can make this much bigger. Let's see. Here we go. So I can see the rendered validation errors here in the test. And then, of course, it's saying I'm unable to find an element with the text username as required. And that makes sense because I updated my error messages. So what I can do is I can go into my test and then I can say, please enter a username and please enter a password. Now it's going to rerun it and it should pass. And I'm going to try to refresh the Storybook. That's okay. I have it running locally. So if I refresh here, then it takes a little while to run the test in Code Sandbox. So if there's any questions right now, this would be a great time. Hold on.
We don't have any questions coming in. For those that may have some, in the bottom right hand of the window, there is a send a question button, and you can submit them that way. It's an easy and quick way to do it.
Awesome. So I think you're just going to have to trust me that it worked. There we go. Took 65 seconds. Man, just right when I need to do a demo, everything is super slow. It's great. So now our test passed because we've updated it. So if you're running this locally on your local machine, it's going to be way faster. But let's move on here. So I'm using Cypress to do functional tests in the browser. And I really enjoy Cypress because it offers a really nice developer experience while testing, similar to using Jest, where it automatically reruns your tests. But Cypress uses Mocha and Chai instead of Jasmine, like Jest does, but it looks pretty similar to our unit tests. And I'm using Cypress testing library in this demo, and it exposes some of the same methods like find by test ID or find by text that I use in my unit tests, as you can see right here. Now, remember that I said that as part of following Storyflow, it's that you write tests against Storybook instead of your actual app. And here at the top, I'm using Cypress to actually visit the dedicated story URL. Now, Storybook serves all the stories in iframes, and you can access any story at its dedicated iframe URL, and that removes all the Storybook UI and only runs the story code. So here, if I go like this is the iframe URL where I can just view the story by itself. Now, I can't run Cypress from within Code Sandbox due to environment restrictions, so I have it running here on my PC. Now, I'm going to use Zoom to flip over to it. So let's go here. And what I'm showing right now, once it shows up, is the Cypress test runner. Now, this test runner interface displays all the tests in my project, all the Cypress tests. And I'll go ahead and click on the login form spec. And hopefully, let's just make sure that our container is up and running. Otherwise, the test is going to fail miserably. There we go. Perfect. Now things are starting to work. So I'm going to launch this. And I'm going to share the testing UI. So one thing you're going to notice here, first, the tests are going to fail, and that's what we expect since we changed the error messages. But check this out. So if I click on this step, it's actually going to show me what the HTML and what the screen look like at the time that Cypress did the test. And I can see clearly that obviously it's not going to find anything called username is required because I changed the error message to please enter a username. So now I can actually go and update that. So let's go into Visual Studio Code. And apologies because I have to keep switching over here. So under Cypress, integration, my login spec. So I'm going to say, please enter a username and please enter a password. And we'll switch back to the testing UI. And suddenly they're working. Now, I think that this is probably the feature that blows people's minds who are new to Cypress, especially if they've come from Selenium-based testing, because Cypress's development time feedback loop is just really, really good. So I can even rerun all the tests here. Just going to rerun it, and I can see exactly where these different things are. Each step, I can even see like where it clicked, and it tells me what the it goes before and after. It's just like it's so good. The way to Cypress is just so useful for this. So I've made it pass. Now remember that the key takeaway here is that this is running against our Storybook server. So I'm testing again the exact same HTML as I am within my unit tests. Now, if there's browser quirks or if I want to test multiple interactions in a workflow, Cypress is a great way to do that. Now, check this out. I'm going to close this and flip back to the test runner. And you can see that there are multiple browsers available. So Cypress can do Microsoft Edge. It can do Firefox and Electron. I don't have the Edge one set up, but there are different browsers you can use, and it can even run headless for continuous integration. So at work, we run Cypress both locally when we're doing development, and then we run it on the pull request as a status check. So it's running inside of our continuous integration server. I'm going to flip back to the slides. All right. So this Storyflow is what we've been following on my latest project at work, and we're building a multi-tenant web application platform. So we have one big repository of components, and we leverage Storybook as our source of truth for all of our testing. Now, Storybook is largely framework agnostic, which makes it a really versatile tool in your toolchain. It provides a way to isolate the development of components, making it easier to share documentation, use cases, and it can serve as a test bed for your unit and functional tests. You can use Storybook to build design systems. You can use it to build component libraries and even your own line of business applications. But sometimes you can also use it to build game engines. Thanks again for listening, everybody. If you want to follow me online, I'm at Kamran Ayub on Twitter. If you want to pursue your dream career as a game developer, you can check out our game engine, Excalibur.js. And if you're a fellow gamer, you can check out Keep Track of My Games. Finally, if you feel like learning even more after the conference, I'm a Pluralsight author and I have courses around Azure, other topics that might interest you. And these slides are available if you wanted to follow along. And the code is also open source on GitHub at these links. So if you want to get to this, it's bit.ly/Storyflow MDC 2020. So at this time, I'm happy to take questions. And if you have anything else you want me to cover, we still have some minutes left.
Yeah, I'm not seeing any questions come through. So, if anyone has them, be sure to get those in right away. Again, that's in the bottom right-hand corner. You can hit the send a question button. And also right next to the send a question button, we have a survey link. And in order to help make, the conference better, help speakers get good positive feedback, please make sure that you go and click the survey button when we're all done with the session. So I'll ask a general question here with the Excalibur.js. Have you guys released any games out of it yet, or are you still really trying to do the game engine itself?
Yeah, so we actually did just release a game this past couple weeks. So we routinely try to participate in game jams, and the one that we usually do is called Ludum Dare. And we've done at least, 1, 2, 3, 4, 5, 6, 7. These are all games that we've done during that game jam. And there was one the week of April 12th. So that weekend, and we did a game called The Show Must Go On. So this was pretty fun. So we tried to test out the Excalibur API and try to make it better by making games ourselves. So this is a pretty fun one. But basically, you're trying to run around and do a one-man play. So that's a kind of fun one.
Yeah. Interesting.
Yep. There's a Pac-Man one that's sort of inspired by Pac-Man called I Just Wanted Groceries, where you're trying to avoid everyone in the store and get your shopping done. We've done the Minotaur swinging an axe, protecting his gold, is from an actual game that we did called Crypt of the Minotaur. And if you like casual games and you want to be addicted, there's one called Sweepstacks, which is pretty fun too.
And if anyone wanted to get in touch to help contribute to Excalibur JS, where would they go?
Yeah, so we have a contribute link, and we're on GitHub. So we have I would say, plenty of community contributors. I think we're up to 52 now. But each release, there's always a few features that are contributed by the community. So Eric Onerheim is the brains and the core maintainer of Excalibur JS. I help out doing some of the input development and DevOps stuff. Like I presented on Storybook, I'm the one that's integrating Storybook, doing the DevOps automated pipeline stuff. And then I have done some like keyboard, gamepad, mouse integration and stuff. But all the math heavy stuff, that's Eric's game.
Excellent. Well, those are the questions that we have now, and so without any other ones coming in, that might be a wrap. And I want to say thank you to Kamran and attendees, and look forward to seeing you in future upcoming sessions.
Awesome.
Thanks,
Well,
everybody.
thanks again.